Solving quadratics by factoring, trinomials. In the last concept, we talked about factoring binomials. That's whenever we had two terms. We would either pull out a greatest common factor and or use difference of squares. In this concept, we're going to factor trinomials, so we'll have three terms to factor here. Okay, we're going to start by looking through our steps for factoring. But the first thing I want to make a note of, and I want to make sure that you write down, is to make sure that the first thing you do is set your equation equal to 0. So if you are solving an equation, then there will be an equal sign in the equation. Sometimes there won't be an equal sign, and you don't have to worry about this step. But if there is, you need to make sure that your equation is set equal to 0, and it's in this form right here, with x squared, then x, then no x. The other thing that you need to make sure that you look for is a greatest common factor. That's going to kind of help you later on not have such big numbers to worry about whenever factoring. Okay, step 1 here is to find two numbers that multiply to AC and add to B. So AC are going to be the coefficients here and here. And B is going to be your coefficient in the middle. We're going to set up these little organizing X things, and we're going to put A times C up here. We're going to put B down here. And then in step 2, still in step 1, it's telling you to find two numbers that multiply to AC and add to B. We're going to put those numbers right here. So I'll show you how to use this X more in an example, but that's what we're going to use to kind of organize our work for that step. Step 2 says rewrite the BX term. So we're going to replace this BX term with whatever the two factors are that we found. Step 3, we're going to group the first two terms, group the last two terms, and pull out greatest common factors. Step 4, we're going to rewrite the expression. And then step 5, if the directions say to solve, we will set each of our terms equal to 0 and we'll solve. That's just like what we did in the last concept. Okay, our first example here, we're going to want to make sure that it's set equal to 0, which it's not here because I have the 14x on the wrong side. So I'm going to add over 14x, and it's actually going to end up going between my x squared and my 33. So we have x squared plus 14x plus 33 equals 0. Okay, next we're going to find the two factors that multiply to A times C and add to B. So start by setting up this x. We're going to put A times C at the top and B at the bottom. So in this case, A is 1. 1 times 33 is 33, and B is 14. Why don't you go ahead and put multiply up here and add down here. So whenever you look back at it, you'll remember what you're supposed to do with those numbers. Okay, so sometimes you're going to find these factors really quickly. You're just going to know two numbers that multiply to 33 that also add up to 14. Sometimes you're not going to know them so quickly, and you're going to need to write out your factors of 33. So the way we do that is we'll just start with 1. 1 times 33 is equal to 33. There's nothing that multiplies with 2 to give me 33, so we'll cross that off. 3 times 11 is 33. And I could keep going, but actually, those will work right there. 3 times 11 is 33, and they add up to 14. So we're going to put them here and here. You're going to save yourself a lot of time if you will just double check this in your calculator. Make sure that they add to what you want and multiply to what you want. A lot of mistakes that are made in this concept are because people have their factors wrong. So just be really careful with that. Okay, the next step we're going to rewrite. So we're going to keep our x squared and our plus 33 equals 0. But we're going to rewrite our 14x term. We're going to use 3 and 11. So let's put plus 3x. Sorry, my pen is messing up. 3x plus 11x. We can do this because 3x plus 11x is the same thing as 14x. So we haven't changed anything really. Alright, draw this line right here in the middle. We're going to look at the first two and pull out a greatest common factor. My greatest common factor between x squared and 3x is just x. And then the last two, my greatest common factor between 11x and 33 is 11. Okay, a couple of tips here. You will always pull an x out of this first set of terms. You might pull more than an x out later on if there's a coefficient in front of the x squared, but at least you're always going to pull out an x. Over here, you will never pull out an x. There will never be an x there. It'll always just be a number, and sometimes it might be 1. Okay, the next thing is these have to be the same. So always double check. I like to squiggle underline them so that I can say that I've checked that they're the same. We're going to write that once. And then in the other parentheses, we're going to use this x and this positive 11. So x plus 11. So this is factored right here. If the directions just said to factor, you would stop. If it said solve, you would set each of them equal to 0 and solve. So we would get -3 and -11. Okay, next one. First thing we have to do again is set it equal to 0. So I'm going to add over the 15x. Remember, it's going to go in the middle because it always goes x squared, x, and then no x. Next, I'm going to look for a greatest common factor. Anytime you have 3 coefficients, other than 1, I guess my last one, my a was a 1, but anytime we have 3 coefficients like this, you're going to look to divide out a number. In this case, we could divide out 5. So put your 5 out front and put what's left after you divide everything by 5. Okay, now I'm going to proceed with factoring, and I'm just going to focus on this. We will deal with the 5 in the end for our factored form. And in fact, I'm remaking this video because I forgot to put the 5 in my answer. So over here, I'm just going to put this so that I don't forget later on. So hopefully I end my problem about right there. Okay, so looking at the x squared plus 3x plus 2, we're going to set up our x here. In the top goes a times c, which is 1 times 2. And in the bottom, we're going to put our 3. Remember, we're going to multiply to this top one and add to the bottom one. The only two numbers that multiply to 2 are 1 and 2, and they also add up to 3. So those are the numbers we're going to use. Okay, so we have x squared and then plus 2. We're going to rewrite 3x as 1x plus 2x. We're going to draw a line down the middle. Look at the first two and pull out a greatest common factor. Remember, you should always be able to pull an x out of this one, which is all we can pull out for this problem. And in the second one, we're always just going to pull out a number. It's never going to be an x. In this case, it's 2 because I can divide both of these by 2. These are the same. So I'm going to write them once and then put this x and 2 in parentheses over here. Okay, if your problem said to just factor, this would be your factored form right here. You have to put the 5 in there. So if your direction said to just factor, that would be your answer. If you forgot the 5, it would be wrong. If the direction said to solve, we would set these equal to 0 and solve, so we would get -1 and -2. Okay, with this next problem, we already have it in ordered, x squared, x, and no x, and it's set equal to 0. And we don't have a greatest common factor because nothing divides 2, -1, and -6. So we're ready to just set up our x. A times c goes in the top, so 2 times -6 is -12. And b goes in the bottom, -1. We want to multiply to -12 and add to -1. So I'm going to go ahead and write out my factors of 12. Don't worry about the negative for now. Just write out your factors of 12. 1 times 12 is 12. 2 times 6. 3 times 4. And we're back to 4. The only pair of these that could add up to a -1, and keep in mind you can put a negative anywhere that you want, would be 3 and 4. So we're going to have a +3 and a -4. Again, the most common mistakes are made right here. You should always double check that they multiply to -12 and add to -1. It's really easy to mess up your signs and then waste a lot of time working out the rest of the problem with the wrong factors. Okay, so we have 2x squared minus 6 equals 0. Now I'm going to be a little picky about which factors I put where. So don't write this down, but I could put plus 3x here and minus 4x here. But these don't have as good of a common factor as if I were to put the minus 4x with the 2x squared. These have a better common factor now of 2x. So I'm going to pull a 2x out. And over here, likewise, they have a good common factor of 3. Okay, these are the same and these are the same. So I'm going to write that once. And then 2x and 3. It's going to be plus 3 since it was a +3. Okay, if the directions said factor, you would have stopped here. If they say solve, we would set them equal to 0 and solve. With this first term, x minus 2, you probably know that when solving it, it's just going to be x equals a +2. With the other one, people try to do this in their head, but that's where they kind of get messed up. So I really think that you should write it out and show work. So subtract over the 3. And then divide by 2. We get x equals -3 over 2. So there are your two answers. Okay, with this example, it's already in the right form, and there is not a greatest common factor because nothing divides 5, 18, and 9. So we're going to start by setting up our x. A times c goes in the top, so 45, 5 times 9, and b goes in the bottom, -18. We're going to multiply to 45 and add to -18. So maybe you know what the factors are right off the top of your head, maybe you don't, but let's write out our factors of 45. 1 times 45. 2 does not divide 45, so 2 doesn't work. We have 3 and 15. 4 doesn't divide 45. We have 5 and 9. 6 doesn't divide 45. 7 doesn't divide 45. 8 doesn't divide 45. And we're back up to 9. So now we really only have 3 factors to pick from, and the ones that could add up to a -18 are 3 and 15. We just need to make both of them negative. Again, this is where you need to double check that they add up to -18 and multiply to a +45. That's the most common mistake that people make. Okay, we're going to rewrite, so we have 5x squared plus 9 equals 0 over there. Okay, and I think I want to pair up that 3 with the 9, so I'm going to put minus 3x here, and then plus 15x here. So notice that 5 and 15 have a common factor, and 3 and 9 have a common factor. Oh, I think that should have been a -15. Sorry about that. Okay, so with the first pair, we're going to pull out a 5x. If I divide them by 5x, I get x minus 3. And in the second pair, notice how it starts with a negative. Anytime it starts with a negative, you're going to need to pull a negative out. So we're going to pull out a common factor of -3. If I divide them by -3, I get x minus 3. Make sure that these are the same. And then we have x minus 3. And then 5x minus 3. If the problem said factor, you would stop here. If it said to solve, you would set them equal to 0 and solve. This first one, we would get x equals a positive 3. The second one, we would make sure that we show our work for. And we get 3 and 3/5. Okay, I want you to pause your video now, and I want you to try these two problems on your own and see what you get, and then restart your video for the answers. Here's my answer for the first problem. Note you might have switched these two. You might have put the negative 2x first and the 4x second, but in the end we would still get the same answer. And here's my answer for the second one. Again, you might have switched this 1 and the negative 10, and that's fine. You should get the same answer.